What is design of experiments? Design of experiments is actually a statistical technique that was derived by engineers, and it's actually a way for marketers to figure out what's important. The basic idea is that you look at what variables are important. You also wonder, do these variables interact with each other? And finally, how do they relate to some kind of outcome? And so here's an example of design of experiments. And again, what I'm looking for is significant factors. Which of these variables are actually significant? For example, I want to see if people are going to buy clothes for tall people. So I pick a response variable. What am I interested in? I'm interested in what's going to generate the most sales. What I think is going, then I pick my variables that I think define that. So I'm just going to say it's age, sex, and height. And now I pick my levels of experiments, meaning for each of those control factors, what values do I want to use? Now naturally, the more levels I can pick that I want to test at, I get more accuracy. Here's the problem. I have 3 variables I'm looking at. Now, if I say I want 4 levels for age, 2 levels for sex, and 3 levels for height, that means I have 4 times 2 times 3, which means 24 combinations. That's a lot of tests. And so in general, what they do is they try to pick 2 levels. And through those 2 levels, you pick a range where you think you're going to see a lot of activity. Now, what do I do for variables that don't have numbers, like male or female? You just assign an arbitrary value. So you have a low-level value, which is minus, and a high-level value, which is considered to be plus. So age, I'm looking at the range of 18 to 50, sex, male and female, height 60 to 80 inches. And so I have enough spread, and then what I do is just run my experiment. Now, the experiments, again, minus is a low level, plus is a high level. So experiment 1 is, I'm going to pick, let's see, what was men? Okay, I'm going to pick young men, minus being the young age, minus for B being men who are short, 60 inches. So that's minus, minus, minus. And then plus, minus, minus would be men who are older, who are men, and the other minus would be who are young. Now, the thing I'm concerned about, though, is the interaction effects, meaning is there a combination of A and B that also gets produced, or A to C, or B to C, or A, B, and C? So as you can see, you can create a lot of variables. And so how do I calculate the effect that each of these variables have? Well, what I do is there's the high level effect and the low level effect. The way I calculate it is I look at all my variables that are high value, and then I compare it to sales. And so I add all of them up and divide by the number of positives I have. That's my effect plus. So let's do it for variable A. For variable A, I have 70 plus 35 plus 20 plus 80. So all of those, and I have 4. So I add all of those up and divide by 4, and my effect plus comes out to 51.25. Now, I come up with my total effect. Effects, now, to see if it's significant, I don't care about the sign, but that sign will be important. And what I do is I compare that value to the average value of sales. And typically you're looking for something above 10%. Here's where the slope comes in. If my slope is positive, then what I'm saying is that for men, sales aren't that high, but for women, sales are very high. And so and if the slope is in the opposite direction, it means that men, sales are high, women, sales are low. And so What I found out from that data is the largest effects have to do with sex and height. The thing is, height interacts with other variables. If I want to, I can do a regression. I could do a curve fit to the data. But right now, I'm just interested in the significance. So I can compare it to the average value, or I can run t-statistics. And what t-statistics are, is it's a measure of whether or not two variables are related to each other. And so we talked about the value of the slope. Here's a second example. Okay, I want to sell sweaters. And so I'm wondering, under what conditions are people interested in buying sweaters? So is it about the color? Is it about the thickness? Or is it the time of year? Meaning, will people only buy it at Christmas, or will they buy it other times? And so I do my runs. And so I could do all 8 combinations of pluses and minuses. And then I'm going to ask moms and grandmas, okay, from a scale of 1 to 100, based on that description, are you going to go ahead and buy it? And so dark sweaters that are thin during Christmas, for moms, what's the likelihood that you would go ahead and buy that? And so the mom says, oh, from a scale from 1 to 100, I guess 80. And grandmas say, nah, I wouldn't do that. I'll give it a 20. And so this is where I can take all that data. And now what I do is try to figure out the effect. So the effect for moms is for color. What's the effect of it? Again, it's all the positives. So that's the 30, 20, 90, and 60, minus all the negatives. And I'm dividing by 4. That's the way to do the calculation. Now I know what you're going to say. Dr. Cho, aren't there computer programs that do this? And the answer is, yeah, there are. But for right now, I just want you to see the raw way of doing it. So that's how I calculate it for moms. Now, what if I want to look at the effect of how do they care about the thickness of the sweater? And so I do those calculations again of figuring out the pluses and the minuses, divide by 4. And as you can see, the effect is actually really high. Now, what if I want to do it for grandmas? Do grandmas care about the time of the year? And so I go through the calculation again. This example, there are lots of papers online for you to read through this if you're confused. And if you're still confused, ask me some questions. Now, what if I don't want to do all these runs? Well, there is something called a half factorial. And there's also something called aliasing, meaning when you go through the mathematical combinations, you find out you're repeating things. What if I have a monster matrix? What if I have like 20 variables or something like that? Well, there's a way to reduce it or to figure out the combinations you need, and it's called Plackett-Burnham, and there are tables for that. If you want to get into deeper analysis, there's something called ANOVA. For those of you who take statistics, you'll learn about that later. But what ANOVA is I have this big variance from the average. And so where's all that variance coming from? And what ANOVA does is it's a mathematical technique that tells you where it's coming from, what factors. To do a good design of experiments, you have to randomize your run. And the reason why is if you make small changes from one to another, just change one variable, you could build up bias. You want an answer that's fresh. When you pick a range that's far enough so you can see what's going on. But by the same token, don't pick things which are going to be too extreme. And like, for example, if you pick a value where automatically everything goes to 0, then you have no idea what's working or what's not working. If your data doesn't look precise, like for example, I pick an age range from 10 to 80, well, nothing seems to be really going on. So I'm going to tone it down. I'm going to make it 20 to 60. And so you can have more precision. How many data points do you need? Well, actually, for each of those runs, you should get 10 plus data points. And a lot depends on the repeatability. And that has to do with statistical significance, which I won't go through in this class. So in terms of going out and getting this data that I can plug into my design of experiments or run my design of experiments, how do I take surveys? and that'll be in the next video.